My practice involves protected land in an area of eastern Canada referred to as the Greenbelt. This land is a protected area in Ontario, Canada, which includes farmland, forest, and wetlands. The purpose of the Greenbelt is to preserve natural space and ease pressures on municipally funded infrastructure. Currently, developers are positioning themselves to continue their surge of single family dwellings into the land that has been protected with taxpayer money for future generations. Residential development in the Greenbelt will lead to increased ecological impact by eliminating integral native watersheds to support the water table in the southern region of the province. This also leads to increased costs for taxpayer-supported municipal services, infrastructures, and increased strain on water resources. Municipal services that developers have already stated they will not be investing in. This project's success will be found in the contextualization of the scale of the intended developments by highlighting the large number of single-family dwellings that are currently available in the selected areas. This appropriated data will be supported with AI-based images created by DALL-E. The primary goal of the project being to combat the apathy towards rebellious acts carried out by local governments with taxpayer dollars through data and visualization. This will hopefully stimulate local communities to investigate further and react. In my previous work, I focused on politics and what led us to consider the development of protected areas. In my current work, I am using a subtler approach by using quantitative research to visualize residential development supply. Location keywords are sourced via a natural heritage area map. This map outlines natural heritage systems, woodlands, wetlands, ANSI land, greenbelt land use designation, and more. This map also outlines greenbelt and escarpment boundaries, and for the purpose of this project, it is used to pinpoint locations that are scheduled for development. These locations act as a center point in a 5-kilometer search radius. Once the radius is established, outlined locations are cross-referenced with a real estate marketing website. Images from all the single-family residences that fall within the radius are collected and layered into a single image. At the base of these layered visualizations are landscapes that have been artificially created via the AI software DALL-E. In the past few years, the field of artificial intelligence has been making tremendous strides in various domains, including computer vision, natural language processing, and machine learning. One of the most exciting developments in the field is the emergence of generative models which can create images, videos, and even text that are almost indistinguishable from those created by humans. As I have been working on this project, the AI-based imagery has confirmed the flawed ideas of the picturesque. Caroline Blinder's statements regarding David Punter's concept of comfort flanking in imagery gives an idea as to why the AI works as it does. Rather than show us the toxicity of the landscape as something that overtly disturbs the eye, it is made palpable in other more subtle and often paradoxical picturesque ways. As advanced as these processes are, they pander to the paradox of human ideas of landscape existing exclusively in the picturesque. They can also be flawed regarding accurate representations of the landscapes, especially as it relates to infrastructure, time, and agency. In a previous module, I was experimenting in photographing different elements that represent the infrastructure of cities. One of the things I focused on was where the power lines existed and the communities they existed in. While generating images for informing context, the AI was including infrastructure such as electrical towers that were a fraction of the size and much less imposing than what actually exists, even though specific keywords such as Ontario and Canada are used. DALL-E should know what the electrical towers look like based off this information. However, the AI chose to minimize their impact on the landscape so that they are not a focal point that interferes with the intended picturesque reading of the image. In 1839, the daguerreotype made it possible for ordinary people to have their portraits made rather than just the wealthy and the powerful. This allowed for a wider range of people to be represented in art and helped break down social barriers, taking a fundamental step in the democratization of art. DALL-E can be seen as the modern version of the daguerreotype, as it is making it easier for anyone to create and share images without requiring specialized artistic skills or expensive equipment. The software generates original images based on their own textual descriptions, which can range from simple phrases to complex sentences. Roland Barthes states that the photograph mechanically repeats what could never be repeated existentially. This statement can also be applied to the AI software used in DALL-E. While the system is capable of generating an almost infinite variety of images based on different textual inputs, it is not capable of generating the exact same image twice. The generated images are based on random variations in the neural network. The software will only show what you request to show it. So much like the practice of point and mechanical camera, it only shows what the artist chooses. The artistic works of Kensuke Koke, Corinne Vianette, Megan Gould, and Gerard Richter had a significant impact on my exploration of using appropriated images in surrealist automatism. However, it was Jason Sullivan's pieces such as City, Shoes Domestic Production, all the ways, and homes for sale that inspired me to adopt a quantitative research methodology for my project on the Greenbelt. When working with images in this methodology, one of the challenges is making the collective parts visible enough to be represented while simultaneously not becoming a specific focal point to the image itself. Jason Salavon spoke about this similar instances when developing his project Self-Portrait. How to bound and render visible a complicated dataset while at the same time making artistic choice and action within or upon that set legible as a gestalt. Moving forward with this project, I would like to include some empirical research developed around how a Turing test is executed and use it to collect two sets of data. One set of data will evolve around whether human respondents can decipher between genuine imagery or AI imagery that is raw from the software, specifically targeting what the respondent sees when deciphering AI from genuine. Secondly, I would like to have the respondents communicate what the compiled images read like to them. The combination of these two datasets will answer some critical questions regarding the overall believability of AI imagery. Do appropriated images made with AI change the perception of how the images are read, and are they read the same way as genuine images? This research will warrant continuing to use AI-based appropriated images throughout my FMP or proceeding with genuine images to represent my practice.